Hello everyone. In this video, we are going to learn about modules in Python programming. So why the modules are necessary? So before starting on with modules, let me explain about the script first and how the script are connected to or linked to modules. So let's see what is script. So if we quit from the Python interpreter and enter it again, you may use any type of Python interpreter. It may be Python idle, Anaconda, Spider, Jupyter, anything it may be. So when you enter it again after quitting from it, the definitions that we have made, and the definition can be in the form of functions or variables, they are actually lost. So therefore, if we want to write a somewhat longer or linear program, then we are better off using a text editor to prepare the input for the interpreter and running it with that file as input instead. So this concept is basically is known as script or script creation. So as your program gets lengthier, you may want to split it into several files for easier maintenance, and you may also want to use a handy function that you may have written in several programs without copying its definition into each program. Now let's come to modules. So a programmer may find themselves writing the same function over and over again in multiple scripts, repeatedly writing it in multiple scripts, or creating very long and difficult to maintain scripts. So a solution is to use a module, okay, instead of repeatedly writing in different places. So which is a file containing a Python code. The module is a file containing a Python code that can be imported and used by scripts, other modules, or the interactive interpreter. Okay, so there are various forms of creating module and importing them to use them further. So we are going to explore some of the options. Okay, let me show you. I'm going to create one program I have already created. So using Python idle, my favorite text editor, and here the name of the file, as you see, is fibo_1.py. So it's stored. This is the path of the file where it's stored. So in the C drive, you just under my name directory, full modules there, the file is located. Okay, and these are the following content. So as you see, this is one function, and here this is another one function. Now, if we want to execute this file fibo_1.py, so what are the different forms of um, using them, or how to access the functions in the Python shell? So the first I'm going to enter the Python interpreter and import this module with a command. So let's see that command. Import the file name. Here the file name is fibo_1. So the file is imported. That means all the functionalities in the file fibo_1 is also imported. So actually this does not enter the names of the functions defined in the fibo directly with the current symbol table. So it only enters the module name, that is fibo_1 there. So now using the module name or function name, using the module name, we can also access the function. So how to do it? You can use the file name that you imported, and let's say this time I want to use the fib function. So here when you enter the module name, it will display you the available functions names that you have. So here the code is for generating the Fibonacci sequence of a series up to n, whatever n argument will be passed in the function. For that, up to that amount, that value, the Fibonacci series will be created. So let me enter a 5. So this is the Fibonacci series based on the logic that I incorporated here. You're getting the series within 5. Now let's try to use the same module name, and here I'm going to enter this one, fib2. I'm going to see what is going to happen when I try to access the fib2. So here, as you see in the logic, we have created one result list. In the list, all the numbers getting generated in the sequence are going to be stored in the square brackets as a list format. Now let's say there are different forms of let's say if you intend to use a function, often you can assign it to a local name. So what is local name? Let me create one local name, let's say Fibo. This Fibo can be created with the file name that we have, Fibo underscore one dot any function. So that function definition will now be incorporated and added to the local variable Fibo that we created. Now using the local variable name that we created and using a sequence, again I want to enter 5. So for this, now the local variable Fibo is able to access the function, okay, that we created earlier. So this is using the local name. So each module has its own, each module in each program or Python code has its own private symbol table, which is used as a global symbol table by many, by or all of the functions defined in the module. Thus, the author of a module can use global variables in the module without worrying about accidental clashes with the user's global module. So on the other hand, if you know what you are doing, you can touch a module's global variables with the same notation used to refer to its function, such as your module name and the function name or item name, that whatever you want to access. The module can import other modules, and there is a variant of the import statement, a different kind of statement that imports names from a module directly into the importing module symbol table. So how to write that? Let's see. From sorry, the module name, that is Fibo1, I want to import. Let's say you have not already imported the module, so at the same time along with the function name you want to import the module as well. So this is the format you can also do. And let's say you want to find out what is the function of fib. So use the function name and just add the series up to what you want to find out, the Fibonacci series, and that will give you the required sequence. And there is even another one variant, another one statement to import all names or all the functions, what any names in the module that you have. So here, rather than specifying the specific name of the modules, what you can do, from module name, import, what do we want to import? We want to import everything. So you can just put one asterisk and it will import everything from the module. So now if you will use the function name that we have for fib, okay, so let's see whether it's giving the sequence. Yes, it is. Now here, this imports all the names except those beginning with an underscore. So what's that? I will tell you in another one example. So actually this is not an ideal format of importing because sometimes it often causes poorly readable code. Okay. Now, so if a module name is followed by edge, okay, then the name following edge is bound directly to the imported module. This is another format of creating import statement. So how to write it? Import the module name edge, then use a local variable. So now using the local variable, what you can do, this local variable can now access the fib function now. Okay, so let me enter the number and see it's giving the same thing. Let me try if the fib2 function can be accessed with the local variable or not. Yes, it is. Now there is another one format. So this type of format can also be used when utilizing with the similar effects. So let me show you one example from the module name Fibo underscore one. Sorry about this. Now Fibo underscore one import. What you can do, import the fib add Fibonacci. Okay. So now using the Fibonacci new local variable that I created, I can access my function through the Fibonacci local variable now. This thing is also possible. So for efficiency reasons, each module is only imported once per interpreter session. Therefore, if you change your modules in any way, you must have to restart the interpreter. Okay, or if it is just a module you want to test interactively, there is a different way of using it, using a reload function. How, I will tell you in another one video. Okay, so I am going to show you another format of it here. This is the same kind of program. I have fib1, fib and fib2, two functions. Let me, yeah. So there are two functions, and here I'm going to use this type of format. So this module, okay, when let's see, if I save it and run it, there, it needs some argument, command line argument in order to execute the program. Okay, because of this statement. So here we are importing the system library, and in order to run the program, we must have to go to the start menu and look for the command prompt. This program need to be run from the command prompt. So how are we supposed to run it then? So here you need to provide the specific path in which this module is present. Here see the module name is fibo underscore 2.py, which is inside modules. Modules is inside the path specified. So I just need to change my directory to modules here. Now enter the modules. Now directly I have access to the fib underscore 2 Python module. So the command is supposed to be like this: Python. Then you have to specify the file name with the extension, and here see this printing the function fib with an argument. So what argument is this? This argument 1, that is the first one and only argument, is supposed to be entered for n. So this argument I am going to provide. So let's say I want to find out the series within 5. So here it is showing the series in this way. Let's suppose rather than fib, I try to incorporate the logic of fib2. So here I can change the name of the function, save it, then for running it, here see the Fibonacci series is supposed to be generated in the format of a list. So fibo underscore 2.py the module name, and same again 5. I want to enter. Here see the list is generated with the proper Fibonacci sequence within the 5. So these are the different ways of creation of modules, scripts, and then different types of import statements that I have shown here. Okay, hope you understand.